Hi everybody, these are the notes for section 4A, the mole and molar mass. In these notes you're going to learn what a mole is, and you're going to learn how to calculate the molar mass for an element and a compound. At the top of the page it says, I'm sure you're familiar with the following counting units. We all know a dozen is 12 things, a couple is 2, and a gross is 144 or 12 dozen. Well, a mole is just a counting unit that we use in chemistry to count atoms or molecules. We can't possibly count them one by one because they're too small, and so we count them in bunches using a number called the mole. And a mole is a number that you need to know and memorize. It's 6.02 times 10 to the 23rd. It's otherwise known as Avogadro's number. It's an SI-based unit, and it actually has a lot of digits. It's something like 6.0221408557 times 10 to the 23rd. But if you can know 6.02, I'm happy with that. Just to give you an idea of how big a mole is, a mole of marshmallows would cover the United States to a depth of 105,000 kilometers, or 6,500 miles. Here's another little factoid. If an Avogadro's number of pennies, or a mole of pennies, were distributed evenly among the 4.9 times 10 to the 9th human inhabitants of the earth, each man, woman, and child would have enough money to spend $1 million every hour, day, and night, and still have over half of it unspent at death. That's insane. That's how big a mole is. The next term that I want you to know is the term molar mass. Because atoms are so small, we count atoms by mass. So each element on the periodic table has a molar mass. The molar mass is by definition the mass of 6.02, whoops, that's supposed to be a 6.02 times 10 to the 23rd atoms of an element. The molar mass of an element is found on the periodic table. It has the same numerical value as the atomic mass of an element, and I'll talk about that in a second, except that the units are grams, not atomic mass units. Get out your periodic table and find carbon on the periodic table. It's element number 6. And excuse me. In the box under carbon, you'll see a 12.01 in the bottom of the box. That is the molar mass of carbon. So when I ask you how much does a mole of carbon weigh, you'll say it weighs 12.01 grams. If I ask you how much a single atom of carbon weighs, you'll say it also weighs 12.01. But the unit will be atomic mass units, or AMUs. Atomic mass units are incredibly small. 1 AMU weighs approximately 1.66 times 10 to the negative 24th grams. But look at how cool that is. So if you're talking about a mole of carbon, you can get the mass of a whole mole of it, and it's 12.01 grams. If you want the mass of a single atom, it's the same number, but just with a different unit, a much smaller unit. Here's a little picture that kind of ties everything together. If you look at aluminum on the periodic table, it's element number 13. You'll see it has a mass of 26.98 grams if you have a mole of it. And if you have a mole of it, you will have 6.02 times 10 to the 23rd atoms. On the accompanying worksheet, you'll be asked to solve a series of questions using the words you have just defined. What follows are 2 examples that you should mimic when you complete your worksheet. When I ask you for a formula, you're just going to write the formula for the element or compound named. Here, the element named is potassium, so you will write the symbol for potassium, or K. Next, I'll ask you for an atomic mass if, in fact, this is an element. This is the mass of 1 atom of potassium measured in atomic mass units. An atomic mass unit, remember, is a mass unit used to measure very tiny objects. 1 AMU is 1.66054 times 10 to the negative 24th grams. I think there might be a typo on your paper where this negative isn't there. You can go ahead and put that in there. And this value, remember, is taken from the periodic table. So if you find potassium on the periodic table, it's element 19 in the bottom of that box. You'll see the mass is 39.10, and since we're talking about an atomic mass, you should put units of AMUs. Now the molar mass is the mass of a mole of potassium atoms, or the mass of 6.02 times 10 to the 23rd atoms, measured in grams. It has the same numeric value as the atomic mass, but it has the unit of grams. the molar mass is 39.10 grams. Lastly, I'll ask you for the number of atoms. This is asking you how many particles are in a mole of something. A mole is 6.02 times 10 to the 23rd things, and because these are atoms, we say we have 6.02 times 10 to the 23rd atoms. In this next example, we're dealing with a formula. Write the formula for the element or compound named. In this case, it's strontium nitrate, so we'll write the formula as Sr in parentheses NO3 taken twice. Next, I'm asking you for a formula mass. Notice it's called a formula mass and not an atomic mass because we have a whole formula here. To determine this, you're going to need to add up the atomic masses of all of the atoms found in the formula. So I've gone ahead and looked up the mass of strontium and nitrogen and oxygen off of the periodic table. You can confirm these numbers if you would like. The next thing I'm going to do is I'm going to take the mass of strontium and I'm going to multiply it by 1 since there's only one strontium atom in that formula. That gives me 87.62. Next, I'm going to take the mass of nitrogen, which is 14.01, and I'm going to multiply that by 2 because I've got 2 nitrogen atoms in the formula. Here we go. So I'll make that a 2. 2 times 14.01 is 28.02. Finally, I'm going to look at oxygen. The mass of oxygen is 16. Now, in nitrate, there's 3 oxygens, but I have twice as many as that. So I have 6 oxygens. I'll multiply 16 by 6 to give me 96. If I add those numbers together, I get 211.64. Since this is asking me for a formula mass, I put 211.64 atomic mass units. It's supposed to be a U there. The next thing I'm asked for is a molar mass. This is the same numeric value as the formula mass, but this time the units are in grams. Therefore, my answer is 211.64 grams. The number of formula units. The number of particles, this is the number of particles in a mole of a substance, and it's always 6.02 times 10 to the 23rd. So I have 6.02 times 10 to the 23rd, and since I'm talking about an ionic compound, that would be formula units or F units of strontium nitrate. Finally, I'm asked for the number of atoms of oxygen in a mole of strontium nitrate. Well, for every formula unit of strontium nitrate, there are 6 atoms of oxygen. So if you have 1 mole, or 6.02 times 10 to the 23rd formula units of strontium nitrate, you actually have 6 times as many atoms of oxygen. We'll fill out this little chart here. We're going to take 6 times 6.02 times 10 to the 23rd, which gives us 3.612 times 10 to the 24th atoms of oxygen. So this is the answer that goes in this box. That should be enough to get you started on the worksheet on the next page. Good luck, and just see me if you have any questions.